Alright, welcome again in another tutorial of the topic differentiation. So in this tutorial tutajifunza how to draw a curve using the concept of differentiation. So kwa nyuma ulikuwa unaweza kuchora curve lakini ulikuwa unatumia table of values. You draw your table of values, x values and y values. You determine the values of y for various values of x. Locate the points in the graph, unaziunganisha. Well, there's a simpler way. We can use the concept of differentiation to draw a graph of a function, a curve of a function. So check out this example. It says sketch the curve of the equation y equals to x power 4 minus 6x squared plus 8x plus 10. So now, in order to draw the graph using the concept of differentiation, there are steps to follow. So this is step 1. So it says, determine if the curve is symmetrical about either or both axes of coordinates. So kuna symmetry about the x-axis na kuna symmetry about the y-axis. So symmetry about the y-axis ipo hivi. So if this one is the y-axis, right, this one is the y-axis. So it means the curve that is symmetrical about the y-axis ni nusu huku, okay, alafu nusu huku. Doesn't matter the shape it takes, lakini kwamba the y-axis divides the curve into two equal parts. Okay, similarly, nikisema symmetrical about the x-axis, manake the x-axis divides the curve into two equal parts, kama hivi. So this now is our x-axis, okay? It doesn't matter the shape it takes. So we have one half upande wa huku and another half upande wa huku. Okay, so I divide it into two equal halves. So how do you determine now if there is a symmetry about the y-axis and a symmetry about the x-axis? So in order to determine there's a symmetry about the x-axis, the equation should only contain even powers of y. So this was our equation, remember? It was y is equal to x power 4 minus 6x squared plus 8x plus 10. So it should have only even powers of y that are symmetrical about the x-axis. But we have an odd power of y here because y is just y power 1 and 1 is not an even number. So we know that it is not symmetrical about the y-axis, about the x-axis, okay? Then symmetrical now about the y-axis, it should only contain even powers of x. So x power 4 is an even number, this is an even power of x. X power 2 is an even number, this is an even power of x. But x power 1 is an odd number, so this is an odd power of x. So it's also not symmetrical about the y-axis, okay? So our curve is not hapa and it's not hapa, okay? So I repeat again, in order to determine that there is a symmetry about the y-axis, you have to look, the equation must contain only even powers of x. And in order to determine that it is symmetrical about the x-axis, the equation must contain only even powers of y, which is not the case for our equation. So that was step 1, to determine if the curve is symmetrical about either or both axes of coordinates. Jambo la pili sasa, step ya pili. Step ya pili inasema to determine if there is symmetry about the origin. Okay, so symmetry about the origin ni kwamba kwanza curve inapita through the origin. Okay, pili the origin divide the graph into two equal parts. So this one is our y-axis, all right? And then this one is our x-axis. So symmetry about the origin ni kwamba graph inapita kwenye origin na divide it into two equal parts, okay? Whatever the form or shape it takes. So in order to determine that the curve is symmetrical about the origin, a change in sign of x causes a change in sign in y without altering its numerical value. So this one was our equation. It was y equals to x power 4 minus 6x squared plus 8x plus 10. Because symmetry about the origin occurs kwamba kama x ni 1, nikichange sign ya x, okay, value ya y inayopatikana na yenyewe ina change sign, lakini numerical value inabaki vile vile, kwamba kama ni 4 basi inabidi iwe negative 4. Okay, so let's consider for 1 now. Nikiweka 1 hapa, 1 minus 6 is negative 5 plus 8 is 3 plus 10 is 13. Nakuta y inapata 13. It means if this curve is symmetrical about the origin, then y should be negative 13 when x is negative 1. Lakini nikiweka negative 1 hapa, inakuwa ni 1 minus 6 is negative 5 minus 8 is negative 13 plus 3 is negative 3. So you can see change in sign in x has not changed its sign in y. The value has completely changed. So we have determined now that our curve is not symmetrical about the origin. Okay, don't mind the spelling, just understand the concept. So symmetrical about the origin. So that was step 2. Now step 3 now, what you're going to look at is that seek the values of x which make y square negative and therefore y imaginary. Sasa, nikisema the square root of negative 1, okay? Jibu lake ni nini? Kwa unavyofahamu wewe ni kwamba there is no answer, okay? Because negative numbers do not have a square root. Lakini you'll come to study a topic called complex numbers, ambapo the square root of negative 1 or any negative number, the square root of negative 1 precisely gives a I, which is an imaginary number, okay? So now, kwenye mambo ya curve sketching, okay? If a value of x, it leads to a value of y which is imaginary, it means the graph does not pass through that area of x. Yani, if this one, right, if this one is our y-axis, if this is our y-axis, and this is our x-axis, and this one is our x-axis, okay? Kama somewhere hapa at x equals to negative a, okay? The value of y is imaginary, manake curve haipiti kabisa hapa. Okay? Manake hakuna value of y hapa. So now check out in our equation. This is our equation, okay? Inasema y equals to x power 4 minus 6x squared plus 8x plus 10. Now note kwamba y will become imaginary if y squared is negative. Okay, manake the square root of y squared, which should give y, will give imaginary number, okay? So you can see now here in our equation, all values of x will bring a value of y, all. Okay, so there is no single value of x that will give an imaginary number for y. So our domain is x is an element of all real numbers. Okay, so our graph itapita across all values of x, okay? Kuanzia x paka x is negative infinity paka x. Kwa hiyo hakuna imaginary number, okay? So that is step 3. So we have now step 4. So this is step 4. Step 4 now it says find where the curve crosses the axis of coordinates. Manake hapa nataka tutafute x-intercept and y-intercept. So I know you're familiar with these two. X-intercept and y-intercept. So x-intercept is where the graph crosses the x-axis. Manake is a point of x, value of x for which y is 0. Wakati y-intercept is where the graph crosses the y-axis. Kwa hiyo it's the value of y when x equals to 0. Okay? So if the value of y is equal to 0 when x equals to 0, it means the graph passes through the origin. So we are going to, ukiona kuna x-intercept na y-intercept, So it means the graph does not pass through the origin. Okay, au labda zipo unakuta ina pass through the origin, lakini pia kuna sehemu nyingine tena ina pass through x. It's a very complicated graph. So let's check it out from our equation. Our equation was y is equal to x power 4 minus 6x squared plus 8x plus 8x plus 10. So this one was our equation. So now, what is our y-intercept, okay? So it means when x equals to 0. When x equals to 0. Tunaona hapa nikipachika 0, 0, 0, y-intercept inakuwa ni sawasawa na nini? Na 10. So this is where the curve crosses the y-axis. So I mean, if this now is my y-axis, okay, so this one is my y-axis. Okay, and this one now is my x-axis. And this now is my x-axis. So it means hapa kwenye y equals to 10 ndipo curve itakapofanyaje? Itakapopita. So what about the x-axis now? It means when y equals to 0. When y equals to what? To 0. So when y equals to 0, nitakuwa na 0 is equal to x power 4 minus 6x squared plus 8x plus 10, okay? So you can see now, kupata x hapa ni changamoto, so tuiache tu. We'll just use the y-intercept and other information to draw the graph, okay? So this equation does not pass through the origin. Because when x equals to 0, you don't get y equals to 0. And when y equals to 0, you don't get x equals to 0. So the graph does not pass through the origin. So that was our step 4. So now, next is step 5. So step 5, it says, find the values of x, if any, which make y very large, and the values of y, if any, which make x very large. So this was our equation. It says y equals to x power 4 minus 6x squared plus 8x plus 10, okay? So ni value gani za x zitafanya y iwe kubwa? Utaona kwamba value kubwa za x zitafanya y iwe kubwa. Kwa sababu value ya x ambayo ni kubwa kuliko zote hapa ni x power 4. Kwa hiyo nikiweka value ya x kubwa, maana kama labda milioni moja, x power 4 maana itakuwa ni milioni moja power 4. Nikija nikitoa na hivi vingine, nitapata a very large value of y, okay? So I mean y is large, all right? When x is large, okay? So you just need to use your brain there. So what does this mean? This means that na sio hivyo tu, also when x is negative, okay? Unajua negative number power 4 inaleta positive number. So when x is large, large negative, yani kama ni negative milioni moja, value ya y pia itakuwa ni kubwa sana. Sasa na kama x ikiwa milioni moja. So when positive x is large, au when negative x is sijui nisemaje sasa. Because negative, yani ni kama is hivi yani. Let me just draw the curve and you get the point, okay? So if this one is our y-axis, okay? This one is our y-axis. And this one is our x-axis, all right? So it means, let's say happen is a very large value of positive something, I don't know, positive milioni moja, okay? Na huku ni negative milioni moja, okay? So the values of y zitakuwa kubwa, okay? You see, like this. Na huku itakuwa nini? Kubwa. So hapa labda ni milioni, I don't know, 10,000. So you see, au laki moja. You see, so this is what we have come to observe here. So when x, positive values of x zipo huku, na y itakuwa kule juu. And when negative value of x zipo kule, na y itakuwa kule juu. So this is what we have observed here in step 5. So now, Next is step 6. So step 6 says if the curve passes through the origin. Tuishia hapo. Alright, tulishaona kule nyuma kwamba the curve does not pass through the origin. Kwa the rest of the blah blahs, kwa heri. Next now is step 7. Okay? So it's called step 7. It says now find the turning points and point of inflection by the methods of this chapter. So nimeshafundisha kwenye tutorials zilizopita jinsi ya kutafuta turning points na jinsi ya kutafuta point of inflection. So let's do this now. So our equation was y is equal to x power 4 minus 6, apologize, minus 6x squared plus 8x plus 10. So in order to find the turning point, we first have to find the dy dx, then equate it to 0. So it's a polynomial function. So my dy dx, okay, fanya kwa kichwa tu. It's just 4x cubed minus 12x plus 8. Okay? So I'm going to equate this equals to 0. So 4x cubed minus 12x plus 8 is equal to what? 0. So I can factorize this. So you shall do it mwenyewe factorize. You'll find out that it's going to be 4. It's going to be x minus 1 squared. And then we have x plus 1 plus 2, equals to 0. So the values of x, itakuwa ni x sana 1 or x is equal to negative 2. So this one are the what? The turning points. X equals to 1 and x equals to what? Negative 2. So we need to determine this turning point if they are either maximum or minimum, okay? What are we going to do? We have to find the second derivative. All right, the second derivative. So this one is our first derivative. It says that dy over dx is just equal to 4x cubed minus 12x plus 8, okay? So our second derivative now, fanya tu kwa kichwa, itakuwa ni 12x squared minus 12. Hiyo hapo, okay? So remember our turning points zilikuwa ni x equals to 1 and x equals to negative 2. Alright, so nikipachika 1, what do I get? Second derivative. Nikipachika 1 pale napata 12 minus 12 is 0. So it means this one now, kumbuka nikipata 0, it means this one is a point of what? Of inflection. Alright, so tupachike negative 2, tutapata ngapi? So it's gonna be negative 2 squared ni ngapi? Positive 4 times 12 48. It's gonna be 48 to 12 is positive 36. Positive, okay? So our x equals to negative 2 is what? Is a minimum point, yeah. Because when the second derivative is positive, then the point is what? Minimum. All right? Yes, so it's a minimum point. Now, from the information tulionao sasa tunaweza tukachora curve yetu. Okay, so the curve of y is equal to x power 4 minus 6x squared plus 8x plus 10, all right? Here. Okay, so we have our y-axis. So this one now is our y-axis. So this is our y-axis. And then follows our x-axis. So this one is our what? Is our x-axis. So hapa now is, remember y-intercept ni 10. So here now is something 10, okay? So at x equals to negative 2, tuna minimum point. At x equals to 1, tuna point of inflection. So hapa tuna minimum point. Also remember graph when x is very large, when negative x ni huku, y ni large, okay? So it's like this. mpaka kwenye minimum point, okay? Ndio mwisho wake. So kwa sababu hapa ni minimum point, maana hapa lazima tuje juu. So it does not pass through the origin, so bila shaka itapita somewhere here mpaka i-cross kwenye nini? Kwenye -10. Alright, ikifika hapa kwenye 1, it's gonna be a little bit parallel because it's a point of inflection. And then last but not least, akasema kwamba when x is very large, na yenyewe inakuwa nini? Y ni large. Kwa hiyo kitu kama hichi. So this now is the graph of our curve. Hatujachora table of values, hatujafanya nini? Tumetumia nini? Concepts of differentiation. So this is our minimum point. And this one is our point. This hapa kwenye 1 is our point of what? Inflection. So that's how you sketch a graph using the concept of differentiation. Let me just say, see you in the next tutorial.